Hello everybody and welcome to this new tutorial on this introductory Arduino workshop for Istituto Marangoni. Today we're going to see one of the sensors we have added to the kit, which is the ultrasonic rangefinder sensor, which is basically, as previously expected, a source of ultrasonic frequencies and a little sensor that can sort out the distance of an object by calculating the time that the waves comes back, which is the very same technique used by bats or other animals. First of all, I have put all the codes and the libraries and the examples and the links to the kit on GitHub. What is GitHub? GitHub is social network, so to say, a big repository that allow all sorts of different programmers to save their codes. GitHub is based on a software called Git, which was created by Linus Torvalds, the creator of Linux, to manage and track the evolution of the software, allowing a lot of people to collaborate together to a specific code base. Nowadays, GitHub is used by many different professionals, such as designers or journalists or even translators. So it's pretty common to use this tool, which is designed as a software tool in other scenarios. There are also poets that use GitHub nowadays. So I advise you to create an account on GitHub, but you are not obliged to. So if you don't want to create an account, you can simply go to this link over here, which is going to be sent to you by the teachers, and download the code, or even copy and paste the code even without downloading it. So you can see here there is the kit. So you have all the links to the CStudio wiki, and also today we are going to see these libraries, how we're going to use libraries, how to install libraries, and so on and so forth. So in order to properly use the ultrasonic rangefinder sensor, let's see what is written in the wiki from SID Studio. So this is the explanation on how the sensor actually works. These are all the details, like the distance that the sensor can perceive, its weight, and so on and so forth, its degrees of the angle, which hopefully are really narrow. The board is working with, we're going to use it with Arduino, and in order to use it with Arduino, we have to download the library. So you can either go here, or you can, and you're asked to download it, or you can click here, ultrasonic.h, which is the very same link, so you're going to be prompted to download this zip file, or you can go in distance.ino is the example software I made for you, and in this comment you can look, you can simply go exactly in that link. In order to install that library from the Arduino IDE, you are going to go in Sketch, Include Library, Add Zip Library, and you're going to look for that specific library which is going to be in your download folder. If you have correctly installed the library, you will then be able to import it. So if you see here ultrasonic somewhere in this second contributed library part, Grove ultrasonic rangefinder. So if you're able to see this, then you will be able to run this example code. So if you download all the folder of the Fluid Networks workshop, you will then be able to open it. Yeah. Distance. Okay. And well, I have did an LED on pin 5, and I'm hooking up the ultrasonic rangefinder on pin number 0, D0. They are all digital. So actually, um, my design looks like this. I have the border over here. On this pin, I have the sensor on pin number 0, D0, and on pin number 5, I have the push button. I have created this software that allows me to check the distance from the... Now I'm going to test how far is the table from the camera that is taping this video you are seeing. So let's go and verify our code. Okay, it compiles, it works. So now, as soon as we cross-check whether the board is selected correctly and whether my board is connected to the computer, which is not right now. Okay, now I'm able to upload. Okay, so let's see this code. The library is imported, a LED is defined on pin 5. This ultrasonic in red is what's called an object of the library. So we have, this basically says, hey, look, we have one ultrasonic rangefinder on pin 0. The setup opens the serial port, we've seen in the last lesson, declares the pin as an output. All I want is range in centimeters to be populated by the measure in centimeters function of the ultrasonic library. And then I'm going to print this out. Okay? So I'm going to comment these things out. We're going to go through the lesson about what I want to do here. So I'm just going to upload this on the board. So if I open the serial port right now, it's giving me the distance between the sensor and the camera. So if I move the camera, yeah, it's 23 centimeter, for example. If I pass my hand, is 10. There is also another way to see a single number using the serial plotter. So actually, you have this data visualized, which is pretty convenient from debugging reason. Also, look here. Actually, we have between 24 and 23 a slight noise, which is something we're going to discuss further in the next lesson, how to um, clean that signal, because this is not 24. This is, I think, between 24 and 26. I'm not given that date, that number. Or if I want to check it, maybe I have to do this. Yeah, 24, 25. It's, noise. But that noise can create us some problems in the future. Now I want the LED hooked up on pin 5 to represent the distance on a light level. So we're going to take this sensor and send it to the LED. In order to do that, all I'm doing is to take range in centimeters and pass it as a variable in analog write. So the LED should be faintly blinking. The LED is 23 right now, okay? If I move it around, it's blinking a lot because now it's 511. But if I got closer and move, it changes even more. Now I'm not able to show you what is going to happen because, yeah, I don't have arms long enough. But the problem is that the resolution of the PWM, which is the amount of data we can send throughout analog write, is 8-bit. What does it mean? It means that it can take the minimum amount of value he has is 0, the maximum is 255, 2 on the power of the 8. While the rangefinder is giving us a minimum value of 0 and a maximum value of 500 and something. So what happens if we were able to visualize the light is that from 0 to 255 the LED is going to increase, but on 256 the LED is going to be lit off because 256, if it's sent inside of an analog write, it values 0. So how to solve this? In order to solve this, I declared a value variable in which I take the range in centimeters variable, which goes from a minimum of 0 to a maximum of 50, 30. And I'm going to map it from 0 to 255 because I want the spread of the LED to be as much as mapped on the distance between the sensor and the camera. So let's see what happens. So it's better to uncomment and print out all the centimeters and the values on the same line. So I took it off the print line over here. I'm just have a new line when the value is printed, so we can start over and have the range in centimeters. So I'm going to upload this and see what happens. So 23 centimeters corresponds to 195, which is a huge amount of light based on the amount of the maximum amount of 255. What happens if I take it up? Okay, well, I was touching the maximum amount of light, which is going to decrease up until 1 centimeter, which is the minimum. Okay, so we were able to read an ultrasonic rangefinder data. Now I have an homework for you. So we have seen that this sensor never goes to 0, which means that if we have an LED, um, that represent the distance, that LED is not going to switch off ever, because that 0 corresponds to an 8, 9, so it's going to be faintly blinking. How and what do we do in order to have that analog write value to goes to 0 whenever the distance is under 5 centimeters? Good work. You can give me the answer in the next lesson. See you in the next lesson then.